Hello everyone. So today we are going to solve the problem tree construction. Okay, it was the B question from ICPC Prelims 2024. That prelim just got rescheduled because of some technical issues. But we are going to solve this question. See, this question says that we have given three integers and D and L. Okay, we have to find a tree of diameter D with nodes N and out of which L nodes will be leaves. Okay, and if such tree doesn't exist, we have to claim that such a tree does not exist. Okay, so the diameter of a tree is defined as the maximum pairwise distance between two nodes of the tree, where the distance between two nodes equals the number of edges on the unique path between them. Okay, and a leaf node in a tree is a vertex with exactly one edge adjacent to it. So I'll draw a tree and we'll see what is the diameter of the tree. See, if I have tree like this, so what diameter says? Diameter says is that the maximum distance, okay, between any pair, okay, like we'll check every pair of nodes in the tree, and whatever maximum distance we'll have, it will be the diameter. If I'll take these two pairs, the distance will be 1. If I'll take these two pair, distance will be 2. Now our answer will be 2. Then this with this, it will be 3. So now our answer will be 3. But now we'll take this one and this one. So it will be 1, 2, 3, 4 and 5. Now diameter will be 5. You can see we can't find any pair which will have distance more than 5. So diameter of this tree is 5. Another thing is leaf nodes. Leaf nodes are the nodes in the tree which are connected with only one component. So this is leaf node, this is leaf node, this is leaf node, this is leaf node, and this is leaf node. Okay. If our tree is like this, okay. So these two are leaf nodes. Despite of this node being as a root, okay, these both are leaf nodes. Okay. Now, what question says that we have given N, D, and L. So for 3 to 3, okay, 3 to 3, N, D, L. Okay. So what we have to do? We have to use three nodes. Okay. Then diameter will be 2, and we need all three nodes to be leaf nodes. So can we create 1, 2, okay, and 3. Okay, now we got D equal to 2. We got two nodes as leaf nodes, but we can't have third uh, third node as a leaf node in any case. So our answer will be -1 because that type of tree doesn't exist. Okay, another test case is 4 to 3. For 4 to 3, let's first construct a straight tree. 1, 2, 3. Okay, we created our straight tree with diameter 2. Here D equal to 2. Okay, now what you have to do? We need only like already we have two leaf nodes. We just need one more leaf node, and the remaining node is fourth node only. Okay, so we can just add 4 here. Okay, so see this tree. Okay, we have 3 leaf nodes. Okay, this condition is true. Do we have 2 diameter? Yes, 1, 2, 2 diameter. Did we use 4 nodes? Yes, 1, 2, 3, 4. So what is possible construction for this tree? 1 connected with 2, 2 connected with 3, and 2 connected with 4. This is our possible answer. Okay. So we'll see how we are going to solve this question. Okay. So I have already here my notion. Okay. So what will be the first hint? So the first hint is, for what value of d there exists only a fixed type of tree. If you'll see, if I have d equal to 1, okay, I have d equal to 1. So only 1 connected with 2, okay. This is the only possible tree. I can't add like if I'll add another node at this point or this point, it will going to increase the diameter, okay. From 1 it will become 2. So for d equal to 1, the possible answer is just one node connecting with another. Okay. So if I have given d equal to 1, then L should be equal to 2. Leaf node should be equal to 2. If leaf nodes are greater, like is not equal to 2, there is no any possible tree. Okay. So for if d equal to 1 and L is not equal to 2, our answer will be -1. Now, another case is d equal to 2. For d equal to 2, you can see if I have this point 1, okay, 2 and 3, okay. This is my tree with diameter 2, okay. Now, if I have any other node, if I want to add any other node, I will add here, okay, 4 here, okay, because if I'll add this point, okay, it will going to change diameter, okay. Diameter will become 3 now if I'll add fourth from 2, okay. So now it has compulsion on me to add nodes from 1 only, and whatever node I am going to add, it will be the size of 1, okay. Even if I'll add fifth node from fourth, okay, like this, it will going to change diameter, so it's not possible. So I'll add 5 here only, then 6 here only. So what you can see, if I have d equal to 2, my structure will be like a star, okay. From a point it will like a star. So you can see only one node is at center and all other nodes are leaf nodes. So if I have given n as a node and d is equal to 2, so L must be equal to n minus 1. So if d equal to 2 and L is not equal to n minus 1, then we can claim that our tree doesn't exist, okay. And see, after this case, if we have d equal to 1 and L equal to 2, then we have to just print 1 and 2, done. And for this case, if we have d equal to 2 and L equal to n minus 1, we'll just print 1, 2, 2, 3, 3, 4, 4, 5, like that, n minus 1 and n. No, sorry. Okay, this is wrong. Okay, we'll print like this. Okay, 1, 2, 1, 3, 1, 4 to the end 1 n. Okay, this will be the structure of our tree if we have d equal to 2 and L equal to n minus 1. So these two are the, like, you can say like edge cases, okay, where we have a specific type of tree. Now, what is second hint? So second hint is, what are the minimum and maximum leaf nodes a tree can have with diameter d and nodes n? Okay, this is very important. See, if what we'll do, what compulsion I have? I want a tree with diameter d. So what I'll do, I'll first create a tree with diameter d, okay, a straight tree. So if I have a straight tree like this, okay, this is my straight tree, okay, 1, 2, 3, 4, 5, 6, 7. So here d is 6, okay, diameter is 6. So let's consider that I have to add how many nodes? I have to add, let's say 10 nodes, okay. So I will add 10 nodes such that my leaf will get maximized, okay. So what I can do, I will add one node here, another node here, another node here, because I am adding at this position, okay, only one node, okay. So what will happen, my diameter will not going to change, okay. If I'll traverse from here 1, 2, 3, 4, 5, 6, diameter was 6. Even if I'll go here, it will be the 6. Even I'll go here, it will be the 6. So I'll add all those 10 nodes, okay, at this place, okay, and all those nodes will be single, like it will not be like this, okay. If I'll add an x node here, so I will add x plus one node next to x, okay. I will not do that, because what I have to do, maximize I have to maximize this leaf nodes. So from this, if remaining nodes, okay, remaining nodes are 10, then what max leaf I can create, these are 2 plus remaining nodes, because we already created 2 leaf nodes in our straight tree. And what are remaining nodes? These are just n minus d plus 1, because we had n nodes and we use d plus nodes to create our straight tree, okay. So it will be just 2 plus n minus d plus 1. This is these are our maximum, like maximum leaf that are possible, okay. Now what is the case of minimum, okay. So if we'll think readily, okay, 1, 2, 3, 4, 5, 6, 7. So in our example, when uh, we had what we were trying to maximize our leaf nodes, okay. So what we did, we didn't extend our nodes with another node here. When I connected x with 2, I didn't connected any other node with x. So what will happen, um, we'll get one less leaf node, okay, in this case. And we don't want to minimize, we wanted to maximize. So what we did, instead of continuing that another node from x, we added that over here, okay. So in that case, our leaf nodes got maximized. Now we want to minimize them. So if we want to minimize them, the best chance is that whatever possible maximum path we can create, okay, we have to find that path, like size of that path. See, if this is our tree, okay, and I am at this position, okay. So from this 1, 2, 3, and 1, 2, 3, okay, this is my mid position. So from this position, what I can do, I can add now see, I have to add 10 nodes, okay, and I have to minimize leaf nodes. So what I'll do, I'll add nodes like this, okay. this is 8th node, 9th node, and 10th node. Okay, so it will also of length 1, 2, 3. So even I'll start from this position, okay, 10th node, and go to the 7th node. So diameter will be 1, 2, 3, 4, 5, 6. Okay, diameter will not going to change. Why? Because from this midpoint, what we did, we added nodes such that the path will be of the size d by 2. Okay, so from any point I'll start, the diameter will not going to change. Okay, it will be the same as d. And we use three nodes. Okay, we use three nodes to just add one more leaf. Okay, so we kind of minimized our leaf. Now I'll add another path of size 3, 11, 12, 13. Okay, now from 10 I did one path with 3 size, another path with 3 size. I can make another path of 3 size also. So like this. Okay, so 14, 15, and 16. So I used 9 nodes for just 3 leaf. Okay, and now I am remaining with one node. Okay, so I'll just add one more node here. It will be our 17th node. So you can see what we did. We kind of added nodes as which are d by 2 in one path. Okay, in one path, when we'll add nodes equal to d by 2, we will not going to change our diameter, and we will use maximum nodes to create just one leaf. Okay, so how can we create a formula here? So we have remaining nodes, okay, which are n minus d plus 1. Okay, these are our remaining nodes. Now consider we have max length. Max length is d by 2. Our path will not exceed size of d by 2. If will exceed size d by 2, then our diameter will change. Okay, it will get increased because there will be some corner leaf point from where we can traverse more than d distance if we'll exceed the d by 2 size. Okay, max length. And consider that we have max position also. Okay, this position, because from this position only I can create like a path of size 3. Okay, if I'll go here, I can't create path of size, let's say this is x, this is x plus 1 node, and this is x plus 2 node. Okay, if I'll create a path of size 3, so my diameter will change. See, 1, 2, 3, 4, 5, 6, 7. Now it has become 7, but actually what was our diameter? It was 6. So we have to find such position. Okay, this is our mid position from where we can add our like path of size d by 2. So what we need, another thing is max position. It will be d plus 2 by 2. Okay, like if you have a straight tree like this, 1, 2, 3, 4, 5, like from 1 to d plus 2 d plus 1 nodes, if we will use to create our straight t of diameter d, then max position will be at d plus 2 by 2. Now uh, we haven't formalized that max leaf. Okay, we already have we have max leaf, okay, which are 2 plus n minus d plus 1, but now we need minimum leaf. So what are minimum leaf? Okay, so we already have 2. Okay, we already created our 2 leaf in our straight tree. Okay, now seal of remaining nodes divided by max length. These are minimum possible leaf we can have with our remaining nodes. Because see, we had 10 here and max length possible was 3. So 10 by 3 and its upper seal which was 4. So we created like the possible structure was with 1, 2, 3 and 4 leaf nodes. Okay, this is our first, second, third and fourth leaf. Okay, now we got two things that our minimum leaf will be this is possible minimum minimum leaf nodes. Okay, now if in any case we have given leaf nodes are less than minimum leaf and our L will be greater than max leaf, okay, then our answer will be -1. Okay, our L should be lie between minimum leaf and maximum possible leaf. Okay, if it's out of that range then answer is -1. Now another hint is, if I have a straight tree with diameter d consisting of d plus 1 nodes, which is the best position to add all other nodes so that tree's diameter will not be affected. Okay, we already see that our mid position will be the best position where we can add all other paths. Now next hint is, when adding nodes from best position, how will you decide the number of nodes to add in a path such that all remaining nodes are included and you end up with desired number of leaf nodes? Okay, see, we'll take this example again. Okay, how many nodes we had? 1, 2, 3, 4, 5, 6, 7 and 10 extra. Okay, we had 17 nodes. We need diameter of 6. Okay, and how many leaf nodes? 1, 2 and we added extra 4, so 6. Okay, 17, 6, 6. Okay, we'll take this case, 17, 6, 6. So we already know that the tree is possible for this. Okay, so we are not going to check again that case. Okay, like we are not going to count our minimum possible leaf, maximum possible leaf. Okay, so if I have d equal to 6, this will be my straight tree. Okay, of diameter 6. So now I'm remaining with 10 nodes. I know this is best possible position. Okay, this is my optimal position from where I can add another path. Okay, in my tree I'm remaining with my 4 leaf nodes because 2 are already covered here. Now what is max length? Now it's 3. Okay, I can add a path with size 3. So if I'll add a path of size 3, my next remaining nodes will be 7 because these are 10. Okay, if I'll 3 more node from here, okay, in the same path, so my remaining nodes will be 7 and my remaining leaf will be 3. If I'll have 7 nodes and from which I have to make 3 as leaf node, is that possible? Yes, is that possible? So it's possible. So what I'll do, I'll add a path of size 3. So 8, 9, 10. Now I'm remaining with 7 uh, 7 nodes and remaining leaf nodes are 3. Now can I add one more path with size 3? So I'll remain with 4 nodes, and from which 2 will be mm, yes, 2 will be leaf nodes. Okay, like that one path will create one leaf only. So I'll remain with 2 remaining leaf nodes. So I can create a tree where I'll have 4 nodes, and from which I can create 2 nodes as leaf node. So I will add another edge, not edge, a path of size 3. So 11, 12, 13. Now these are my remaining nodes, and these are remaining leaf nodes. So again, can I add another path with size 3? Then I'll remain with one node, and from which I have to make one leaf node. So I can use one node to create one leaf node, because I'll add just one node here, some x. So I'll added one node, and also I got an extra leaf node. This is possible. So I will add another path of size 3. Okay, because we are at this condition now. Okay, we are remaining with 4 and 2. We just check that is it possible, if I'll create a path of size 3, is it possible that the next configuration we have, the values of R and L, is it possible to create tree with that? Okay, so it was possible. So we added a path of size 3. So it is 14, 15 and 16. And at last we'll add only path of size 1, 17. So this is how we are going to create. Okay. If you didn't understand, basically what we'll do, we'll have some remaining nodes, and there will be a value L, where L is that we have to create L number of leaf nodes. Okay, so if I have remaining nodes 5, and I have to create 5 leaf nodes, so what I'll do, I'll just add like this. Okay, I'll add uh, I'll add all nodes as a leaf nodes by keeping the size of path as 1. Okay, you can see this was our optimal position, and from that we just added nodes with path 1 only. So what happened, our we achieved all 5 leaf nodes, and we used only 5 nodes. Okay, but if I have 4 nodes, okay, and I have to create 5 leaf nodes, this will be never possible, because I have only 4 nodes. From that, how I can create leaf nodes which are more than the remaining nodes? Okay, so at any point we have to check that if I'll add okay, in here, when we came to this point, R is 1, L is 1, we again check for, is it possible to create add another path of size of max length. So it was not possible, because we had only one remaining node. How can we create a path of size 3? So then we decrease it with 1, so it was 2. So was it possible for 2? No. Then we again decrease it, so it was 3. After that it was 3. Our max length was max length was 1. So for 1 it was possible, so we added one path with size 1 only. Okay, after that our remaining nodes was 0, and also our leaf nodes were 0. So that was an end. Okay, we constructed our tree with given input. So that is what we are going to do. What we are going to do, we'll have some max length. We'll remove, um, like when we are going to add a path of max length, we'll use max length number of nodes. Okay, so R minus max length, these are remaining nodes, and if these are greater than equal to L minus 1, because after doing this we are going to make one more leaf node. So if it is greater than L minus 1, then we are good to go. In else case, what we did, we just decreases our max length by 1. Okay, so this thing we are going to do. Now see solution. So for a value of d 1 comma 2, there exists only a specific type of tree. Okay, for d equal to 1, only 2 leaf nodes are possible. In other cases, we'll have minus 1. For d equal to 2, only n minus 1 leaf nodes are possible. Like we saw, it will be a star-like structure. Now we have to think for minimum and maximum number of leaf nodes. Okay, we already saw that. What will be the possible minimum leaf and maximum leaf? If 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 the given given leaf nodes in the input are out of that boundary, like not in that range, then our answer will be the minus 1. See, if these are not in this range, our answer will be minus 1. We saw our max position, like optimal position will be at d plus 2 by 2. Remaining nodes are n minus d minus 1, or we can take bracket here and do d plus 1. Okay, it's same. Our leaf nodes are L minus 2, because after creating straight tree, we already done with our 2 leaf nodes. Now let's construct our tree. Okay, that all remaining unused nodes are in a set. Okay, we'll put all remaining nodes in the set. So we'll have a track of how many remaining nodes we have. Okay, and we can easily access our remaining nodes also. Okay, if we are adding a path of length max length, it will take nodes equal to max length. Okay, we see that if I am adding a path of max length size, I'll have to add nodes equal to max length. So now the remaining nodes will be remaining nodes minus max length, and the remaining leaf nodes will be the remaining leaf minus 1, because that path will create one leaf for us. So if remaining nodes minus max length is less than remaining leaf minus 1, okay, if this is the condition, then we can't add a path of size max length, because it will create a condition where we'll for next iteration will remain with the less nodes and more leaf nodes. So we can't handle that case. Okay, like we can't create more leaf nodes with less existing nodes. Okay, and if that is the case, we'll decrease our max length by 1. In other case, we'll just add that path of size max length. Okay, so where is the code? Yes, we this is our code. So see, we took that test case input, and in void solve we are going to solve. We have ndl, where n is number of nodes, d is the diameter, and l is number of leaf nodes. So if d equal to 1, okay, if l equal to 2, we have answer 1 and 2. In other cases is minus 1. Okay, we have to handle this case here. Why? Because in next process in code, what we are going to do, we are counting max length, which is d by 2. Okay, here d is 1, so d by 2 will be 0, and here we are dividing by max length. Okay, so dividing by 0 in next calculation will cause error. Okay, runtime error. So we are handling this case here. Okay, so after this, if there will be no chance of that, we'll have max length as 0. Okay, for d equal to 2 and our l is not equal to n minus 1, we have to print minus 1. Okay, we saw these two cases. Now our max length is d by 2, remaining nodes are n minus d minus 1, max leaf are 2 plus remaining nodes, minimum leaf are remaining nodes plus max length minus 1. Okay, it was simply same as I'm doing ceil of 1.0 into remaining nodes by max length. Okay, this calculation was, okay, this calculation was same as doing seal. Okay, then max position was d plus 2 by 2. Okay, the position from where we can add a path of size max length. Okay, because we are doing greedily, we are trying that if I'll add path of size max length, after that is it possible to construct our tree? If not, then we are decreasing our max length. So it's important to stay on that maximum position on the straight tree. Now remaining leaf are L. Okay, here I decrease that remaining leaf. Okay, this was the condition where we checking that given input of L is not, if it's not in this range, then we have to print -1. Then we created our straight tree of diameter D, removed those two leaves. Okay, two leaves. Now remaining nodes we added in set. Okay, if set is empty, we are returning. Now if remaining nodes are greater than 0, okay, remaining nodes will be sorry, remaining leaf are greater than 0. Here we are taking remaining nodes as the nodes which are present in the set. So actually it is size of set. Then remaining nodes minus max length is greater than equal to remaining leaf -1. Okay, we saw that this condition. If this is true, then we can add path of that size. Okay, so we'll decrease one remaining leaf, because that path will decrease our like we'll have one more leaf, so remaining leaf will get decreased by 1. My last position is max position. Okay, because I'm uh, adding all those nodes from max position. So I'll take an element from set. Okay, and I'll what I'll print the last element, like whatever our last was in our path, and the current. Okay, current will be the node we got from our set, and now our last will become current. Why? Because when we are adding a path, if I'll add 2 node to 1, okay, now my end point will be the 2. Okay, if I'm adding 3 next to 2, then the last will be my 2. So it is necessary to update our end point. Okay, and if this case is not true, we are just going to in our else loop, in else case, and where we are going to decrease our max length by 1. So we'll run it. Okay, these are some sample tests. See, for 212 it printed 12, because it's possible. For 211 it's not possible. For 213 it's not possible. For 524 it should give a star like structure. Okay, one is connected. Okay, this is wrong. Where it is? Okay, we have to handle that case here also. Okay, because in straight because here we have code of straight tree. Okay, but for this case we don't need straight tree. Okay, we need a star like structure. So it will be if L equal to n minus 1, for int I equal to 2, I is less than equal to n, I plus plus C out 1 and I return. Okay, this will give us right answer. Now see, for 5 to 4 1 2, oh, why it is giving? Okay, the problem was we don't need to handle this here. Now you can see 1 2 1 3 1 4 1 5. For 5 to 5 it will not, there is no possible tree even for 5 to 1, because when diameter is 2, our leaf node must be n minus 1. For 12 at 4 you can see 1 to 8. Okay, 1 to 8, no, 1 to 9 we have a straight tree, so it will give us diameter of 8. After that 5 to 10, 10 to 11. Okay, another our third leaf, and here we got our fourth leaf, so we got configuration with 4 leaf where 8 was diameter and we use all 12 nodes. So this was the code for it. Thanks.